Have you ever walked into a server room or an office network closet and seen cables running everywhere, tangled, unlabeled, and confusing? If you have ever wondered why some networks look clean and professional while others looks like a mess, the answer lies in something called structured cabling. Hello everyone, welcome back to the Network Fixer. I am Mithun, and in this video we are going to deeply understand structured cabling in networking. This is not a quick overview, this is a complete explanation meant for students, network engineers, system administrators, and anyone who wants to understand how real-world networks are built properly. By the end of this video, you will clearly understand what structured cabling is, where it is used, why it is important, how it supports networking, and how it impacts performance, scalability, and troubleshooting in real environments. So let's begin. Structured cabling is a standardized way of designing and installing a cabling system that supports multiple hardware users like data, voice, video, and security systems. Instead of connecting devices randomly with point-to-point cables, structured cabling follows a planned and organized architecture. In networking, structured cabling acts like the backbone of the entire infrastructure. No matter how powerful your switches, routers, firewalls, or servers are, if the cabling is poorly designed, the network will fail. Structured cabling is not just about cables, it is about design, standards, labeling, cable management, scalability, and long-term reliability. In a properly structured cabling system, every cable has a purpose, every port is documented, and every connection can be traced and troubleshot easily. Now let us understand why structured cabling is actually required. In the early days of networking, networks were small. There were fewer computers, fewer users, and fewer devices. Cables were run directly from one device to another without much planning. As organizations grew, networks became larger and more complex. More users, more floors, more buildings, more devices like IP phones, access points, CCTV cameras, and servers were added. Without structure, cabling quickly became chaotic, troubleshooting became difficult, adding a new user required running new cables again and again, downtime increased, and performance issues became common. Structured cabling was introduced to solve all these problems. Structured cabling provides a uniform and organized cabling system that can support present needs and future expansion without redoing everything. In networking, structured cabling is used almost everywhere. It is used in corporate office buildings where hundreds or thousands of users need stable network connectivity. It is used in data centers where high-speed, low-latency connections are critical. It is used in hospitals where network downtime can affect patient care. It is used in educational institutions like schools, colleges, and universities to support labs, classrooms, and campus networks. It is used in airports, railway stations, shopping malls, hotels, factories, and even modern residential buildings. Anywhere you see a professional network, structured cabling is working silently behind the scenes. Now let us understand how structured cabling supports networking specifically. In networking, data travels as electrical or optical signals through cables. The quality of the cable, the way it is installed, and how it is terminated directly affects speed, latency, packet loss, and overall network stability. Structured cabling ensures that cables are installed following standards such as proper length, bend radius, separation from electrical interference, and correct termination. This ensures consistent performance across the network. Another major benefit of structured cabling in network is scalability. When a new user joins or a new access point needs to be installed, you don't redesign the entire network. You simply patch the required port. This is possible only because structured cabling separates permanent cabling from active equipment. The permanent cables stay in place for years. Only patch cords change when needed. This design drastically reduces downtime and maintenance effort. Structured cabling also plays a very important role in troubleshooting. If a user reports a network issue, a network engineer can quickly trace the cable from the user's desk to the patch panel and to the switch port. Because everything is labeled and documented, the issue can be identified much faster. In an unstructured cabling environment, the same issue could take hours or even days to resolve. Now let us talk about how structured cabling is physically used in a network. From the user's computer or IP phone, a cable runs to a wall outlet. From the wall outlet, the cable goes through horizontal cabling to a telecommunications room. In the telecom room, the cable terminates on a patch panel. From the patch panel, a short patch cord connects to a network switch. This separation between permanent cabling and active devices is a core principle of structured cabling. The same concept applies at a larger scale between floors and buildings, where backbone cabling, often fiber optic, connects different network rooms. Fiber is commonly used because it supports high speeds, long distances, and even immune to electromagnetic interference. Structured cabling also supports multiple services over the same infrastructure. The same cabling system can carry data for computers, voice for IP phones, video for CCTV, and connectivity for wireless access points. This reduces cost and simplifies management. Another critical aspect of structured cabling in networking is standards compliance. Standards ensure that cabling installed today will work with future technologies. For example, installing Cat6 or Cat6a cabling allows networks to support higher speeds like 10 gig or 10 gigabit in Ethernet. Following standards also ensure interoperability between devices from different vendors. Now let us talk about the human side of structured cabling. For network engineers and system administrators, structured cabling reduces stress. It makes networks predictable, stable, and easier to manage. For businesses, it reduces downtime, improves productivity, and protects long-term investment. For troubleshooting, it turns guesswork into a systematic process. Structured cabling also plays a role in network security. When cables are properly managed and documented, unauthorized connections are easier to detect. Loose or unknown cables can pose serious security risks in enterprise environments. In real world networking jobs, many performance issues are not caused by routers or switches but by poor cabling. Loose connectors, incorrect termination, cable damage, and interference are common causes of intermittent network issues. Structured cabling minimizes these risks. Now imagine a growing organization without structured cabling. Every expansion would require ripping out old cables. Every issue would require manual tracing. Every upgrade would be expensive and disruptive. With structured cabling, the network grows smoothly and predictably. This is why structured cabling is considered the foundation of networking. You can upgrade switches, firewalls, and servers over time, but if your cabling is well designed, it will support these upgrades for many years. As a network professional, understanding structured cabling is just as important as understanding routing, switching, and security. It is one of those things that, when done right, nobody notices, but when done wrong, everyone suffers. And that brings us to the most important takeaway: structured cabling is not optional, especially in professional networking. It is definitely essential. It ensures performance, reliability, scalability, and manageability. It turns complex networks into organized systems. And also, it allows network engineers to do their job efficiently. So, if you are designing a network, maintaining one, or learning networking, never ever underestimate the importance of structured cabling, because a strong network always starts from the ground up with proper cabling. In real world environments, this is where most networks quietly fail, not because of firewalls, not because of switches, but because of shortcuts taken during cabling. Cables pulled without labeling, patch panels skipped to save time, random color codes, loose bends, no documentation. At first, everything works. Then one day, a port goes down, or a user moves desks, or a new switch needs to be added, and suddenly, a 5-minute task turns into a 5-hour investigation. That's the true cost of poor cabling. Not just downtime, but wasted human effort. Professional structured cabling eliminates that chaos. Every cable has a purpose. Every port has a destination. Every rack tells a story you can actually read. When something breaks, you don't guess, you trace, you verify, you fix. That's the difference between reacting and operating with confidence. Let's talk scalability because this is where structured cabling really proves its value. Networks never stay static. More users, more access points, more cameras, more servers, more cloud connectivity. If the cabling foundation is clean and standardized, growth is painless. You add, you patch, you document, you move on. If it's not, every expansion feels like surgery without anesthesia. This is why experienced network engineers are obsessed with cabling. Not because it's glamorous, not because it's exciting, but because they have lived through the consequences of doing it wrong. They know that a neat rack today prevents outages tomorrow. They know that labels save weekends. They know that standards protect careers. So, whether you are a student learning networking, an IT admin managing a growing office, or an engineer designing enterprise infrastructure, treat structured cabling with the respect it deserves. Because switches can be replaced, firewalls can be upgraded, configs can be restored. So, to summarize everything we have discussed today, structured cabling is the silent hero of networking. It's what makes networks reliable, scalable, and easy to manage. It's what turns chaos into order. It's what allows IT professionals and network engineers to focus on solving real problems instead of chasing cables. When you do it right, nobody notices, and that's the point. The network just works quietly, efficiently, and flawlessly. When you do it wrong, everyone suffers downtime, frustrated users, lost productivity, and endless troubleshooting become daily challenges. Remember, structured cabling is not optional, it is essential. It is a foundation upon which every professional network is built. Treat it with respect, plan it with care, install it with precision, document it thoroughly, label it clearly, follow the standards, think ahead to the future growth of your network because the investment you make in good cabling today will save you countless hours, headaches, and money tomorrow. As a network engineer, student, or IT enthusiast, understanding structured cabling gives you an edge. It makes you not just a technician, but a problem solver, a designer, and a professional who builds network that last forever. It ensures that when the network scales, when users grow, when devices multiply, your infrastructure will remain organized, stable, and ready for whatever comes next. Thank you for joining me on this deep dive into structured cabling. I hope you now have a clear picture of its importance, its applications, and its impact on real world networking. If you found this video helpful, please like, share, and subscribe to the Network Fixer for more detailed, practical networking lessons. Don't forget to hit the bell icon so you never miss a video. And remember, networks are only as strong as their foundation, so always start with proper cabling, proper planning, and proper standards. Until next time, this is the Network Fixer, helping you build smarter, stronger, and more reliable networks. Stay curious, stay organized, and keep fixing networks the right way. Thank you and see you in the next video. Have a great day. Bye bye.